The first step is mounting panel was secured in the vertical position. Then, two adjustable hook was mounted above the beam and secured through hole with nut. After that, the spring was hung on the center hook and connected to the upper hole on the beam. Another adjustable hook was placed through the hole with nut. Then the center hook was adjusted until the hole in the center of the beam lines up with the hole. The spring balance was attached to the upper hole at the edge of the beam with the scale at the end furthest from the beam and hang over the remaining two adjustable hooks. The balance support hook was adjusted so that the large hole in the center of the beam coincides with the hole and the beam is horizontal. Next, we set the balance scale to 0. After that, we measure and record the weight of concentrated load by using digital scale. The unit was changed from grams to Newton. Then, the beam and load for test 1 was set up. The load 5 Newton was placed to the 0.1 Newton weight hook. When the load has been correctly positioned, the hook that supports its spring balance was pulled upward until the beam is supported by the two spring balance and float in the horizontal position with the center hole in line. The reaction was recorded on each balance RA and RB. Then the step 10 and until 11 was repeated for test 2 until 8.
In theory, a beam is horizontal member of a structure which rests on support, often wall or column, and span an open space. If a beam rests onto support without any fixing device, it is said to be simply support. If the load is placed on beam and covers a very short length of the beam, it is called a point or concentrated load. But if the load is spread over an applicable length of the beam, it is called a distributed load. If the support are placed each end of a beam and the beam is symmetrically loaded, the weight carried at each support, called the reaction, must be half the total weight of the beam, as experiment will show. Beams are not symmetrically loaded must still carry the total load at the support, but the proportion of the total weight carried by each support will depend on the weight of each individual load and the position which is occupied along the beam. A beam may also be subject to a moment load M. Imagine that the beam from the left support and the right support has a symmetrical load. So the beam support the load is 1/2 times the total of distributed loading.
So I want to talk about the observation in this experiment. So what we get about the observation is experiment in test 1, lot of 5 Newton in place at the center of the beam. So that distance between left and right to the center is equal. The beam is divided to parts, and you can observe the ratio of the spring balance of RA and RB is equal with equilibrium is achieved. The reading will also change when the load and the load with the separate load is applied. For test 2, the separate load of weight 2.7 Newton placed at the center A and B. So the distance between left or the right to center is equal. So that's all about observation of this experiment, equilibrium of the rigid body. So we got the question about this experiment. So the question is, do our team members provide experimental operation? I say Yes, our team member provide experimental cooperation where they were commitment about making the report, about making the experiment. They very well, so they are good, very commitment about all about this people. So all of us is very good. So that's all about comment this.
Okay, next, for the calculation part, we want to find the calculator bit, which is the theoretical bit. Okay, in this case, we apply the summation of forces with y is equal to 0 and summation of the moments is equal to 0. Okay, for the summation of Fy, we list down all the forces, in this case, we list down all the reaction forces in y axis and the all value of force y axis, and we get one equation which two unknown. Then for the summation of moments, we choose one point which is at the A or B point, and we list down all the force and distance until we get the one forces value, which is when we choose A for the point, we will get the supported reaction at B point. So the value that we get in the summation of moments step, we use and substitute it into the first equation, and we get the reaction forces. How do we get? I will show you the step. Okay, first of all, from the figure, we draw the free body diagram and list down all the forces and reaction force. So for the step 1, we apply the summation of F y is equal to 0. So for the y axis, we have reaction A forces plus reaction B forces is equal to 5 Newton, which is we can choose either up or the down on the positive value. So we get one equation. So we apply the summation of moment, summation of the moment, and we choose either A or B. A is equal to 0. So the moment at A, we have we can choose either clockwise or anti-clockwise to be positive value. So in this case, we can choose anti-clockwise positive value. So we can get RB times the distance, which is 500 millimeter, 0.5 meter minus, because the direction of the 5 Newton is follow the clockwise direction. So minus 5 Newton times to the 0 to 0. So in this case, we get RB is equal to 2.5 Newton. We substitute the value of the reaction at B is equal to RB plus 2.5. So RB is equal to 2.5. So this step will be same for the other figure until the figure A.
We got in conclusion, we are able, from this experiment, we are able to recognize that the total forces distributed load may be considered as equivalent concentrated load acting on the beam at the center of gravity. And secondly, we are also able to understand the reaction at the support due to loading a simply supported beam may be calculated by applying the principle of moment. We also face the problem which is no small weak load as 0.05
Newton to balance the bar accurately. Moreover, we had to define the accurate load to balance the bar in level position. From this experiment, we learned and like to add some suggestions such as maintenance scheduling against apparatus, especially on critical link, movement, and calibration of direct gauge and weight scale. Also, we have learned that preparation before the experiment is so much important and must be done to ensure the experiment done properly with handling carefully during run this experiment. And besides that, we also have to repeat the data measurement in order to avoid practice error. And finally, the group members are giving their effort, great teamwork.
In my opinion, my group have give the top of their performance during the experiment. Overall, everyone have do their job need to do to achieve this experiment. Thank you.
Terima